students. Fourth lesson, Combinatorics and Mathematical Induction. So this lesson, it is useful for the principles of counting and applying into various situations. Second point, to compute the number of ways in arranging a set of distinct objects. To compute the number of ways in arranging a set of distinct objects. To compute the number of arrangements from a set containing identical objects. To compute and apply it to find the number of combinations of a set of different objects. Last one, the obligations of the principle of mathematical induction. So there are some fundamental principles of counting. First fundamental is sum rule. Second one, the product rule. Third one, inclusion and exclusion. So there are three fundamental rules: sum rule, product rule, inclusion and exclusion principle. So first we are going to see sum rule. So sum rule, let us consider two tasks. Let us consider two tasks, A and B. Two tasks which need to be completed. If the first task can be completed in m different ways. First task can be completed in m different ways and the second task can be completed in n different ways. And if these cannot be performed simultaneously, then there are how many ways? M plus n ways. That is m plus n ways. So that is called sum rule. So once again, let us consider two tasks which need to be completed. If the first task can be completed in m different ways, and the second task can be completed in n different ways, and these cannot be performed simultaneously, then there are m plus n ways of doing either task. Then product rule. Let us suppose that task comprises of two procedures. If the first procedure can be completed in m different ways, and the second procedure can be done in n different ways, and the total number of ways completing the task is m into n. So there are two procedures, m and n, then the total number of ways to completing that task, m and n, is m cross n, m into n. The last one is inclusion and exclusion principle. For example, suppose two tasks A and B can be performed simultaneously. Let n of A and n of B represent number of ways of performing the task A and B. So there are two tasks, A and B. The task performing A is n of A. The task performing B is n of B. Independent of each other. Also let n of A intersection B be the number of ways of performing the two tasks simultaneously. We cannot use the sum rule to count the number of ways of performing one of the tasks, as that would lead to overcounting. To obtain the correct number of ways, we add the number of ways of performing each of the two tasks and then subtract the number of ways doing both the tasks simultaneously. This method is referred to as a principle of inclusion, exclusion. Using the notation of set theory, we write it as, so both the task means n of A intersection B. So this can be written as n of A union B equal to n of A plus n of B minus n of A intersection B. This we call it as inclusion, exclusion principle. see the example 4.1. Suppose all of you take the textbook in your hand, because I am not writing the question, I am reading the question. I will solve it in the board. Okay, solve it on the board. Suppose one girl or one boy has to be selected for a competition from a class comprising 17 boys and 29 girls. So in a class 17 boys and 29 girls. In how many different ways can this selection be made? So out of this 17 boys and 29 girls, one boy have to select and one girl. This suppose one girl or one boy, or one girl or one boy has to be selected for a competition. So out of 17 boys, if we select one boy means 17 ways we can select. Am I right? So out of 29 girls, one girl we have to select. So out of 29, one girl we are going to select. So how many ways? 29 ways. So total number of ways equal to 17 plus 29. That you have to add it. So 17 plus 29 equal to 46. Example 4.2. Consider the three cities, Chennai, Tiruchi and Tirunelveli. In order to reach Tirunelveli from Chennai, one has to pass through Tiruchi. There are two roads connecting Chennai with Tiruchi, and there are three roads connecting Tiruchi with Tirunelveli. What are the total number of ways of traveling from Chennai to Tirunelveli? So if you draw the diagram, it is easy for you. There are three cities: Chennai, Tiruchi, Tirunelveli. So from Chennai to Tiruchi there are two roads. So if you consider R1 first road, R2 second road. And Tirunelveli to Tiruchi to Tirunelveli, there are three roads: S1, S2, S3. So we have to find what are the total number of ways of traveling from Chennai to Tirunelveli. If we want to travel from Chennai to Tirunelveli, what are the ways? So R1, S1, first chance. Then R1, S2. Then R1, S3. Then if we select the second road, R2, S1, then R2, S2, then R2, S3. So number of ways is 1, 2, 3, 4, 5, 6. 6 ways we can select. That is the answer. Understand? Then example 4.3. A school library has 75 books on mathematics. 75 books on mathematics, 35 books on physics. A student can choose only one book. In how many ways a student can choose a book on mathematics or physics? So if a student want to select mathematics books means how many ways? Number of ways of selecting mathematics book equal to 75 ways. Then number of ways of selecting physics book equal to 35 ways. So you want to select mathematics or physics book means total number of ways. Number of ways of selecting equal to 75 plus 35. That is equal to 110. That's 5 plus 5, 10, 110, 110 ways. Then example 4.4. If an electricity consumer has the consumer number, say 238 is to 110 is to 29, then describe the linking and count the number of house connections up to 29th consumer connection link to the larger capacity transformer number 238. This is larger, subject to the condition that each smaller capacity transformer can have a maximal consumer link of say 100. This is smaller capacity, consumer, number of consumer 29. So here 110 is there, correct? So 109 transformers means it links to, each transformer links to 100 consumers. Each transformer links to or connect to 100 consumers. So 109 means 109 into 100 consumers. So that is equal to 10900 consumers. And remaining 101 one transformer is there. So 110th transformer links to how many consumers? 29 consumers. Am I right? The transformer, that is one transformer. One transformer in, that is 1 into 29 equal to 29. Therefore the total, what they asked, total number of consumers linked to 238, the larger capacity transformer is total number of consumers linked to 238, the larger capacity transformer equal to, we have to add 1000, once 10,000, 10,900 plus 29. That is equal to 10,929 consumers. That is answer. Then example 4.5. A person wants to buy a car. There are two brands of car available in market, and each brand has 3 models, variant models, and each model comes into 5 different colors as in the background. In how many ways she can choose a car to buy? So there are 2 brand cars. First brand, second brand. So first first brand and second brand. How many models? There are 3 models. 3 models and 5 different colors. So you write, we want to select a car, one car. So 2 into 3 into 5. Am I right? That is equal to 30. 2 3s are 6, 6 5s are 30. So how will you write the step? A brand car can be chosen in 2 ways, a model can be chosen in 3 ways, and a color can be chosen in 5 ways. A brand can be chosen in 2 ways, a model can be chosen in 3 ways, a color can be chosen in 5 ways. So total number of ways of selecting a car is 2 into 3 into 5, that is equal to 30 ways. Example 4.7, sorry 4.6. 4.6. A woman wants to select one silk saree and one singudi saree from a textile shop located at Kanjipuram. In that shop, there are 20 different varieties of silk saree and 8 different varieties of singudi sarees. In how many ways she can select her sarees? So there are 2 types, silk saree and sing saree. So how many silk sarees are there? 20 different varieties. So 20 here, 8. So out of these 20, one have to select. Am I right? So 20 ways. Then out of 8, one have to select. So 8 ways. So 20 into 8, that is equal to 160 ways. So the step you can write like this. The woman can select silk saree in 20 ways. The woman can select silk saree in 20 ways. And the second type of saree in 8 ways. So therefore total number of ways of selecting these 2 sarees is 20 into 8, that is equal to 160 ways. Then example 4.7. In a village, out of the total number of people, 80% of the people own coconut groves and 65% of people own paddy field. What is the minimum percentage of the people own both? So total in a village, how many percentage? 100% of people. So coconut. So N of C, coconut groves can be written as N of C equal to how many percentage? 80%. Then N of paddy field owner is how many percentage? 65%. Am I right? 65%. So total N of C union P equal to 100%. So we have to find N of C intersection P equal to, according to the inclusion exclusion principle, how will you write? N of C plus N of P minus N of C intersect C union P, that is equal to 80 plus 65 minus 100. Am I right? So that is equal to 80 plus 65, 145 minus 100, that is equal to 45%. So you can write that is the minimum percentage of the people who want both. Minimum percentage of people who own both coconut as well as paddy field is 45%. Exercise one problem we can see. Exercise 4.1, first question. A person went to a restaurant for dinner. In the menu card, a person saw 10 Indian and 7 Chinese food items. In how many ways the person can select either an Indian or a Chinese food? So there are Indian Indian food and Chinese food. So how many Indian foods are there? Persons are 10 Indian and 7 Chinese food items. So in how many ways the person can select either an Indian or a Chinese food? So number of ways of selecting Indian food equal to 10 ways. Number of selecting Chinese food equal to 7 ways. Therefore total number of ways of selecting Indian food or either Indian food or Chinese food equal to 10 plus 7, that is equal to 17 ways. First question, second part. There are 3 types of toy car and 2 types of toy train available in a shop. Find the number of ways a baby can buy a toy car and a toy train. So second part. There are 3 types of toy car and 2 types of toy train available in a shop. Find the number of ways a baby can buy a toy car and a toy train. Toy car and toy train. So number of ways of selecting toy car is how many ways? 3. There are 2. So find the number of ways a baby can buy a toy car and a toy train, both. Number of ways of selecting a toy car and a toy train equal to 3 into 2, that is equal to 6 ways. And third part. How many 2-digit numbers can be formed using the digit 1, 2, 3, 4, 5 without repetition of digits? So we have to form 2-digit numbers, 10th place and unit place. So 2-digit numbers, suppose here first digit can be filled by how many ways? 5. Am I right? 1, 2, 3, 4, 5. Second number can be filled by 4 ways. So 5 into 4 equal to 20 ways. So the step we have to write like this. The number of ways, the 10th place can be filled in 5 ways. Number of ways that the unit place can be filled in 4 ways, because repetition is not allowed. So total 5 numbers, 5 into 4, that is equal to total number of ways is 5 into 4, 20. So fourth part. Three persons enter into a conference call in which there are 10 seats. In how many ways they can take their seats? 3 persons. 3 persons enter into a conference hall. There are 10 chairs. 10 chairs. So how many ways they can be seated? So first chair can be selected in 3 persons. What they asked? 3 persons enter a conference call in which there are 10 seats. In how many ways they can take their seats? So first person, second person, third person. So 10 ways, here 9 ways, here 8 ways. So 10 into 9 into 8 that is equal to 90 into 8, 0, 9 8s are 72. So 720 ways. Am I right? So fifth part you try to do as homework, okay? Fifth part, at least one sum you just try. Right.